in order to get our photosynthesis really going, we have to have organization within the chloroplast. You can't just have all these molecules floating around everywhere without any organization. You won't be able to get a lot done. So kind of, if you think about when we talk about enzymes, you know, the molecules have to be able to interact with each other. So here with photosynthesis, same thing. So in order to make sure that this process, this very, very important process for life, gets done in an organized fashion, so that way we can actually get a lot out of it, we have photosystems. So photosystems is going to be a structure that we find in the thylakoid membrane. And this structure organizes everything necessary together in order to trap the energy from light. So when you look at a photosystem, you're going to see that it's made up of proteins, chlorophyll A and B, carotenoids, and some other organic molecules. Don't draw this picture. We'll be taking a closer look at this in class. But this basically is an example of a photosystem. There's multiple parts to it, but it's actually really simple. A lot of times when you look at these diagrams, you're like, oh my God, there's so much to it. But you can really break it down into basic parts. So the first one, in the center of a photosystem, is your reaction center complex. So that's one piece in the center of the photosystem here. Within the reaction center complex, two really, really important parts in this section of the photosystem. There's a pair of chlorophyll A molecules located at one end, and then there's also a primary electron acceptor. This is a molecule that is going to accept electrons from chlorophyll A. Very, very important. Surrounding the outside of the reaction center complex, so picture if this was the reaction center complex, around it is going to be multiple little sections that go around that. Those are called light harvesting complexes. So here there's 1, 2, 3 that we see in this image here. And of course this photosystem has been cut in half so we can see the inside of it. So with these light harvesting complexes, they surround the reaction center complex. And if you were to look what they're composed of, you're going to see that they're composed of proteins, and the most important part of this is going to be the pigment molecules. Now, I just said pigment molecules here because they could be, all of these green circles, which are pigment molecules, could be chlorophyll A, could be chlorophyll B, could be carotenoids. So within a light harvesting complex, you're going to find many pigment molecules inside those. All right, last thing for these notes that we're going to be taking a look at is what goes on in the photosystems in order to trap the sun's energy. So, or trap and convert the sun's energy. So what happens is this is going to be a photon. A photon is going to strike one of the pigments in our light harvesting complex, and that's going to start a chain reaction of electrons being passed around. So when a photon hits a pigment, remember it causes an electron in that pigment to go from a ground state to a higher, an excited state. When it starts to come back down, this time, instead of just releasing energy as heat or releasing the energy in the form of photons as light, as it drops back down, it's going to pass that energy to another pigment molecule, which will excite its electron up to an excited state, from a ground state to an excited state. And then as it drops back down, it's going to pass it along. And that's going to keep on happening from pigment molecule to pigment molecule till eventually that energy gets passed to the chlorophyll A here in the center complex. So once the electron gets passed here, that's a huge, huge thing when it finally gets there, because now it can pass it to the electron acceptor, the primary electron acceptor. Now notice we haven't gotten to ATP and NADPH yet, but this is actually the very first step of the light-dependent reactions, what we just see right here. So I'm going to go ahead and play the animation for you. So here's our photon, and we're going to see what happens when it hits our pigment here. And there you go. Okay, so the photon excites the electrons here in the first pigment that it hits and passes it along till it gets there. Now there's actually two types of photosystems that we see in the thylakoid membranes. There's photosystem 2 and photosystem 1. Photosystem 2 was actually discovered after photosystem 1. So in the early discovery here, this one was actually found first. And you can see they look very similar. The thing that makes them different is first, their order of how they're involved in the light-dependent reactions. And here's what's crazy. Photosystem 2 actually starts off the reaction. So photosystem 2 is first in the sequence of the light-dependent reactions. Photosystem 1 comes second. So that's just something you're going to have to get straight in your head. So photosystem 2 starts off the light-dependent reactions. Photosystem 1 finishes it off. So 2 comes before 1 in this case. Another thing is that their chlorophyll, their chlorophyll A's are going to absorb energy at slightly different wavelengths. So the chlorophyll A's here in photosystem 2 are called P680. That means that they absorb light in the wavelengths of 680 nanometers, whereas with photosystem 1, the chlorophyll A molecules here are called P700 because they absorb light energy best at 700 nanometers. Now, this is what we started off here in these notes. So why do these light-dependent reactions happen? And we said that it's to convert solar energy into chemical energy in the form of ATP and NADPH. And we haven't quite gotten to that yet. We're going to get to that in class. So this background information will make a lot more sense in putting it all together and explaining exactly how you go from the solar energy to the chemical energy of ATP and NADPH.